So in my presentation, I'm going to be talking about sound because ukuleles create sound. First things first is we have to tune the ukulele. Okay, now that's tuned. Okay, so what is ukulele? Ukulele was created in Hawaii around the 19th century, and it's basically a mini guitar except it only has 4 strings instead of 6, and it's a lot easier to play. So on the ukulele we have, here's the tuners, these 4 things. We have the headstock, and right here it's called the nut. Then we have the frets, which are these little things, each one there. Then the fretboard is all of this. This is considered the neck. The whole part right here is called the body. This right here is the sound hole. All of these are the strings. Here we have the bridge and then the saddle. So that is the ukulele. So what is sound? Sound is a mechanical wave. So sound is shown as wavelengths, so shorter wavelengths and longer wavelengths. Vibrations and air pressure and corresponding waveforms is what creates the sound to be able to go to your ear. So the particles of the vibrations move parallel to the direction of energy. So sound is measured in the form of hertz. So frequency is the number of waves that passes through per second so it creates different sounds. All the waves travel about the same speed, so this is the number that each wave will reach the ear in hundredths of seconds. Short wavelengths means lots of waves, which is a higher frequency of sound going into your ears. Then long wavelengths means fewer waves, and low frequency, low sound. So it'll be like a lower deep sound if it has a low wavelength, and it'll be like super spread out like that, when higher would be like that. So each string on the ukulele has a different wavelength frequency of sound. So our first string at the bottom, it's A, and has 450 hertz. Then we have E, 330 hertz, C, 262 hertz, and G, 392 hertz. So the lower, the lowest sounding one has less hertz than the highest sounding one. At the beginning of the video, whenever I tuned the ukulele, when you tune a ukulele, it depends on the tightness, width, and string material. And when it's tighter, there will be less vibration. Yeah, basically when you tune it, it just allows the pitch to be changed. So this is the string super out of tune. And now this is it after I tightened it and put it in tune. It doesn't sound that right, but when it goes all together, it's just how it sounds. Okay, so the next part of the sound ukulele has to do with amplitude. So what the definition of amplitude is the maximum extent of vibration or oscillation measured from the position of equilibrium. So the smaller the amplitude, the softer the sound, and the larger the amplitude, the louder the sound. So smaller, larger. So yeah, difference of the amplitude. So basically when it's super loud, that's larger vibrations. There's a lot more vibration whenever the finger strums the chords, so there's barely any vibration. So the sound is amplified through the hollow body. Here you can see where the hole is. So the sound has to do with energy. So the more energy, the bigger the sound. Less energy, the smaller the sound. So whenever I do that, that's way more energy, creating a larger sound. Okay, so now I'll play Somewhere Over the Rainbow, so you can see the difference. I'll play one softly with low frequency and then one harshly, so you can see the higher frequency. Okay, and that's all you need to know about the ukulele and physics. Thanks for watching.